In this lesson, we're going to be looking at section 11.1, which is dealing with exponents. There are several rules in dealing with exponents. When you're multiplying two powers with the same base together, the base remains the same and the exponents are added. In mathematical terms, if a is a non-zero real number and m and n are integers, which means positive or negative whole numbers, then a to the m power times a to the n power equals a to the m plus n power. So for example, if you have 2 to the 5th power and you're multiplying it by 2 to the 3rd power, or 2 cubed, you can add the 5 plus 3 exponents and get 2 to the 8th power. So remember that if you have, for example, a to the m, your a is your base, and m is your exponent. So we're going to look at the reasoning behind this. And mentions in section 1.6, which we did not have to do for this class, it explained that exponents are repeat multiplication. The exponent tells the number of times that the base is being multiplied times itself. And so if we look at that 2 to the 4th times 2 to the 3rd power to simplify it, we can write 2 to the 4th power as 2 times 2 times 2 times 2. If we expand that out, it's called expanded form. And 2 to the 3rd power would be 3 of them, so 2 times 2 times 2. And so if we write that as the product of those two, we have 2 to the 4th power here. And we're multiplying that by 2 to the 3rd power, so let's expand that one again. And so we can count the number of 2's that we have total, which is 7, and so we can simplify it by doing 2 to the 7th from expanded form back into exponential form. So the easier way to do that is with our new rule. And so 2 to the 4 plus 3 gives us 2 to the 7th power. So obviously they're the same. Okay. Let's look at another idea. When using the product rule for exponents, you are to multiply like terms. So first we can group the coefficients together and group each like variable together and multiply the coefficients together and apply the product rule for exponents to group each of the like variables. And so what they're talking about is, in this example, 4xy times 5x squared y. We'll look at those coefficients. Remember, the coefficients are the front numbers, and we'll multiply those front numbers together. 4 times 5 is 20. And then we add our rule of exponents. So we have a single x here, and we have x squared there. So we're going to multiply those two. And they're showing us here that we have an invisible 1, and x is understood to be x to the 1st power. So 1 plus 2 gives us the 3rd power, or cubed, for our x's. And then for our y's, when they combined our y's together, we have a single y times a single y, or again, 1 plus 1 will give us 2y's, or y squared. So you're multiplying those coefficients, those front numbers, and adding exponents to combine your y's together, your x's together, any variable that they give you. And so let's check these and see if they did these correctly. So we have 2y squared times 3y to the 4th power, and they did 2 times 3, and they got 6, which is good. And then they have y squared times y to the 4th, so they show that grouped together here. They show we're adding exponents, and 4 plus 2 is 6. And so they did that correctly. Now let's look at the second one. We have our coefficients of 4 and 12. So they show us 4 times 12 is 48. That's good. And then we have our A's. We have a single A here and a single A here. Oh, they just showed that we have A squared B for both of them. And so we should have done A times A and B squared times B squared. So we should get our 48. And then if we put our invisible ones there, 1 plus 1 will give us 2. So we'll have A squared, or A to the second power. And then for our B's, 2 plus 2 is 4. So we'll have B to the fourth power. So this one forgot to multiply those variables by adding exponents. It just used it as a like term and kept the exponents the same, which is incorrect for multiplying. So now let's look at dividing, or the quotient rule. When dividing two powers with the same base, the bases remain the same and the exponent in the denominator is subtracted from the exponent in the numerator, so top minus bottom. And so they give us the formula here. As an example, they give us 10 to the 9th power divided by 10 to the 4th power is the same as 9 to the 10 minus 4th power, or 9 to the 6th power. And it says, why is it important that A is not equal to 0? Well, if we had A in the bottom, we're not allowed to have that. So that is why we cannot divide by 0. And so since we have a division, or that denominator in our fraction, we can't have 0. And so we're going to do the same thing that we did with multiplication with our division to show that we have only to subtract the exponents instead of expanding it out. But let's show it expanded out to prove that. So 5 to the 7th power would be 7 5. So 1, 2, 3, 4, 5, 6, 7. And then 5 to the 5th power, we'll give ourselves 5. 1, 2, 3, 4, 5. And so we're supposed to write it with a division, without using exponents. So we're going to put our 5, that are 7 of them, on the top. Come on. There we go. And we're putting that over, so let me draw a big fraction bar. And then 5 of them on the bottom. Let me move it. Run. Okay, let me just type it out. Be a lot easier than trying to play with it some more. So here we have 1, 2, 3, 4, 5. And so that's without it being simplified. Now it says simplifying by canceling like terms. And so anything divided by itself is 1. So these 2 5s can cancel and become 1. These 2 5s can cancel and become 1. Same as these 2, and these 2. So we're left with 5 times 5, which is written as 5 to the 2nd power when we're putting it in exponential form. I know you know that is 25, but it asked us to write it in exponential form because we're trying to prove this rule. So the rule says we can do 5 to the top exponent, 7 minus the bottom exponent, 5. And 7 minus 5 is 2. So again, we conclude that our answer is 5 squared. We get the same either way. So here's an interesting rule that doesn't make sense until you understand the reason behind it. If a is a non-zero real number, then a to the 0 power is 1. 0 to the 0 power is undefined. But this a to the 0 power equals 1. That doesn't make sense, I don't think, until you understand why. Well, we know that anything divided by itself is 1, correct? So for example, 3 divided by 3 is 1. And we can use variables. So we can say a divided by a is 1. Or a to the 4th divided by a to the 4th is equal to 1, right? Because anything divided by itself equals 1. So let's take a look at this last one for a second and use the rule that we just learned about subtracting exponents. When we divide, we subtract. So we'll have a to the top exponent, 4, minus the bottom exponent, 4. And we already know that 4 minus 4 is 0. And we already know that the answer is supposed to equal 1, because anything divided by itself is 1. So we just proved that rule, that anything to the 0 power is 1, because you're dividing whatever it was by itself to get you 0 left as an exponent, because when you subtract them, you get nothing left. Another interesting rule is dealing with negative exponents. If a term has a negative exponent, you write the reciprocal of the entire term and remove the negative sign. So reciprocal, remember, means it's flip, but then I always think of the negative did its job. You remove that negative sign. And so their example, a to the negative 1 is the same as 1 over a. Or 2 to the negative 1 is the same as 1 over 2. And again, they just drop that invisible exponent of 1 there. And so a to the negative n power, whatever integer you want to put there, is the same as 1 over that. And so, for example, 3 to the negative 5th is 1 over 3 to the 5th. So that negative exponent tells you to flip. So in turn, we will see that if you have a negative on the bottom, it would move to the top, because let's do 1 over x to the negative 3. Again, the negative sign means flip, or take the reciprocal. So you would move it to the other side of the equal, or to the division bar, so it would move up. And so we would get x to the 3rd power. As again, once it moves, it's using up that negative sign. And technically, then we would put it over 1, but we know we don't have to write a denominator of 1. Anything divided by 1 stays the same. And so if you have 1 over something with a negative exponent, it moves up to the top and becomes just, in this case, x cubed, or x to the 3rd power. Okay, let's look at an example now where we're looking at a pattern for these exponents. And so for a squared, their example would be 3 squared, which is 3 times 3 or 9. A to the 1st power, 3 to the 1st power is 3. A to the 0 power, remember anything to the 0 power equals 1. So notice it's going down by a unit of 3 each time. And so we haven't established a pattern for the first one, but the second one we can take our previous answer and divide it by 3. And that will give us 3. And then if we do 3 divided by 3, we would get 1. So our previous answer divided by 3 so far is our pattern. So let's see if that continues. So 3 to the negative 1 power, remember that flips. So it's 3 over 3 to the 1st power. We ignore that 1 as an exponent. And so our previous answer is 1. And if we divide that by 3, we do get the fraction 1/3. So that works. And so 3 to the negative second power would be 1 over 3 squared, which we can simplify to say it's 1/9. And so again, our pattern is take the previous answer, 1/3, and divide it by 3, which would give us 1/9. And then for our final one, 3 to the negative 3 power again, that negative says we flip it and make it 1 over 3 to the third power, which 3 times 3 times 3 is 27. And if we take our previous answer of 1/9 and divide that one by 3, you will get that 1 over 27. And so we already saw, if we continue the pattern, what algebraic expression would you need to evaluate? From 0 to negative 1, we did 1 divided by 3 to get that. And we've already done these, so C, we get them to match. And we did the pattern, and yes, the patterns match. So again, we can take it and divide the previous number by 3, since that was the base, or we can follow the rules of our exponents and work it that way. So here's some examples for you to do. Again, when you're multiplying, you add exponents. Notice for number 8, the coefficient, we have -5, but there's no number in front of x that we're supposed to multiply. So if you want, you can pull out your invisible 1. Same thing with your exponents. When you're adding exponents, if there's no exponent there, you can add a 1 to it if you want to, which I don't see any of those here. But go ahead and work through those. And notice this says that make sure all exponents are positive. So let me point out something that we haven't had an example of for number 11. We have 3 times 4. And then we have x to the 5th plus -7. And so 3 times 4 is 12. And then for x, 5 plus -7 is -2. Now we're not allowed to leave that negative exponent. But notice the 12, it's 12 times x to the -2. So it's only the x that has a negative exponent. The 12 doesn't have to move. And so again, if we think of this as a fraction, we can put everything over 1. So the 12 stays up top. It's the x that has to move with the negative exponent. So your answer is going to be 12 over x squared. So again, only the piece, the variable that has a negative exponent moves to the denominator. The other parts, the coefficients or other variables, if they have a positive exponent, they do not move. Okay? Finish working through the rest of these problems and check your work. And when you're done, you can move forward and we'll look at some story problems together. Barbara's Bombastic Bakery makes petit four glaces, which are small bite-sized cakes. Each cake is in the shape of a cube that has a side length of 2x, where x is a positive length which varies depending on the cake flavor. Write an expression using exponents to find the volume of the petit four glaces. Do not simplify. So we have volume equaling length times width times height. So our length is 2x, our width is 2x, and our height is also 2x. Which exponential rule will you need to use to simplify this? Well, we are using the product rule. So 2 times 2 times 2 will give us 8. And then remember, we're adding exponents for x's. We have a single x 3 times. So 1 plus 1 plus 1 will give us x cubed, or to the third power. And so if x equals 2 centimeters, find the volumes. Our volume equals 8 times our x, which we were replacing it with 2, cubed. 2 cubed is not 6, it's 2 times 2 times 2, which is 8. So we have 8 times 8, which equals 64. And remember, this is volume, so our units are cubic. So we have cubic centimeters for our units. A strain of influenza virus is spreading throughout a community, and the number of confirmed cases of the flu doubles every day. On day 0, the initial day of the outbreak, 1 person has a virus. On day 1 of the outbreak, 1 times 2, or 2 people have the virus. On day 2 of the outbreak, 1 times 2 times 2, or 1 times 2 to the second, or 4 people have the virus. And so if we continue on this pattern, it asks us for A, write how many people will have it on day 5. And so we have 1 times 2. And notice day 2 had an exponent of 2. And so day 5 will have an exponent of 5. And then 2 to the 5th power will give us 2 times 2 times 2 times 2 times 2, which is 32 people. So how many people would have the virus on day n if 3 people had the virus on day 0? So remember, the 1 represents 1 person on day 0. So now we're going to have 3 people on day 0. So we'll have 3 times 2 to the nth power. So if we have 5 days of the outbreak, if 3 people started, let's see the difference in people from 32. So we're going to do 3 times 2 to the 5th power, which is 3 times 32, or 96 people. A lot more people infected when 3 people start instead of just 1. And our last story problem to go with this lesson, a standard hard drive has 2 to the 38 powered bytes of data, and a gigabyte is equivalent to 2 to the 30th power bytes. And so write an exponential expression to determine how many gigabytes are equivalent to 2 and 3/8 bytes. So let's divide. We have 2 to the 38th power, and we're dividing it by 2 to the 30th power. We know that the rule tells us to subtract, so we'll have 2 to the 38 minus 30, which gives us 2 to the 8th power. And so that is in gigabytes. I'll just put gigs. Oh, well, I guess we already did that. So simplifying it gives us 2 to the 8th power gigabytes. And what rule did we use this time? We used the quotient, or the dividing rule. Okay. If you have any questions while you're going through this lesson, don't hesitate to email me and screenshot it so I can see what question you're working on. Otherwise, I'll see you next time.